What's up, guys? Mr. Stark back here again. I got a pretty cool experiment that I want to teach you about magnetic induction. So what I did here is I built this little experiment which really simulates a transformer, how a transformer actually operates. And it's on the principle of magnetic induction. And because we can't physically see this, I wanted to show you through this illustration, although kind of dangerous, I still want to be able to make you understand what's actually going on in this. So in this experiment, what I have two close enough to 500-foot rolls of 16 gauge wire. And what you'll notice is they're tie wrapped together. What you don't see is the end of this wire and the end of this wire are in between the spool and they're spliced together. The other ends of the wire, which is here and here, are tied on to a simple power cord. Black to whatever and white to whatever, it doesn't matter. And what I created here is I just wired two 500-foot rolls in series. And because we're in theory, I want to touch on the series circuit and magnetic induction and later in AC theory, part 2. What I've actually done is I've doubled the amount of resistance by tying these two wires together. Now, most people know that in order to prevent a short circuit, all of our electrical circuits on the planet are essentially a short circuit. But what prevents that short circuit from actually tripping the circuit breaker is resistance. So as soon as we put a load into the circuit, which is resistance, it will oppose the flow of current, which is limiting the amount of current that comes out of that circuit breaker so that your circuit breaker doesn't trip. And we do that by sizing our branch circuits effectively, sizing the overcurrent protective device, and then we go to the next job. And if the breaker doesn't trip, we hope that we sized everything accordingly. This experiment is actually something quite different. What's going to happen here is I'm going to put 120 volts between this wire. It's going to go all the way through this coil, which is connected to this coil. It's going to go all the way through this coil, and it's going to come out this wire and want to go back home on neutral. Normally we would think that'd be a short circuit, but I've got a lot of resistance here. I'm going to put an iron core in the center of all this. So you can see all I'm doing is I'm sticking this piece of pipe through the two spools. Kind of cool. Now I have two coils to one coil. What I'm going to do with this coil is, if you can already see, I put a 24-volt lamp and I connected one lead of the lamp to one end of the wire, and I connected the other lead of the lamp to the other end of the wire, which is deep inside the middle. So this lamp is tied into this whole wire from end to end. No shenanigans. Now what I'm going to do, based on the laws of magnetic induction, is we know from study, and if we don't know already, we're going to study about it, if I put current through a wire, I create a magnetic field. And if I create enough of a magnetic field, I can induce or put into that next piece of wire that I'm going to present. How I'm going to do that is I'm going to take this magnetic field, I'm going to turn it on by plugging this in, and what I'm going to do is I'm going to slide this roll over the tops of these like this. And what's happening when I do this, when I bring it up and down, is I'm actually cutting magnetic lines of flux. Because these magnetic lines are actually being induced into this copper shaft, this steel piece of VMT. And that magnetic field then gets coupled into this wire, and we end up getting induced voltage onto this wire, and consequently we get enough of it to turn this light on, which is the same principle as how a transformer works. This would be a 2-to-1 ratio. Double the amount of coil to a single coil, 2-to-1 ratio. Or twice the amount of turns to the secondary. So, I'm going to plug this in and let's watch it work. You're going to hear it hum. Now watch, as I slide this over, there's no electrical wires connecting these. Now watch my light bulb. I want to make sure you see it. See the light coming on? The closer I get to the magnetic lines of flux that are being created, now I'm cutting lines of flux through my movement. So I get closer, the light gets brighter. If I pull it away, the light becomes dim. Hopefully you can see that the light is clearly coming on and there's no electrical connection. It's all magnetic induction, which is basically, we can't see it, but it's happening. Pretty cool, right? So let me unplug this. Once again, magnetic induction. To simplify this again, I wired these two rolls in series. I hooked them up to a 120 volt power cord, which normally if we hook this up and put black and white together, it would trip the breaker because there's no resistance. The reason why the breaker isn't tripping is because we have a substantial amount of resistance on these wires, keeping the circuit breaker from tripping. I'm creating a lot of magnetic field and I'm inducing voltage into these conductors as I close in on the magnetic field when I go up and down. And I could vary this. I could put 3 rolls on the bottom and 1 roll on top, and I could play around with how much voltage I can expect to get out of this through a calculation. I'm hoping this video kind of is cool because you realize that there's no wires hooked up to this light connected to this. It's all done through the magnetic field. So hopefully you enjoyed this, and I'll see you on the next video.